going to start graphing these rational functions, and there are certain steps that I want you to go through every time. When we do these, just like when graphing polynomials on a test or quiz, I will break the problem down into A, B, C, D, and I'll ask for each of these so you don't have to like memorize what each piece is. But the first will be to factor the numerator and denominator. So we will factor the top and bottom of our fraction. Our goal here, we're trying to see if anything is going to cancel out. Second step will be to find the X intercept. And we know that an X intercept is just when y equals 0. Then we need our Y-intercept, and we know that's when x is 0. Then we'll find all asymptotes so we did those yesterday, the vertical, horizontal, and oblique. And we'll plot all of that information and graph. So that is what we're going to be doing today. Sometimes, I've kind of touched on this before, we might get a hole in the graph. For instance, if I gave you a function and said it was this. Okay, we know that what can happen to those x minus 3's?
Cancel out.
They would cancel out, and all we're left with is x plus 3. But these things are actually not equivalent, because could you have put 3 into the original? No, because it would have given us a 0 on the bottom. So typically, whatever's on the denominator gives us a vertical asymptote. But when something cancels, it makes a hole in our graph. We will need to find that, and it will be an ordered pair. The x value comes from the piece that cancels. What makes x minus 3 equal 0? 3. To get your y value, you plug 3 into what's left. So 3 plus 3 is 6. When we graph these, a hole is just an open circle. And then x plus 3, that's a line. Y-intercept of 3, slope of 1. So our final graph would look like this. One thing that I want to caution you on, your graphing calculators will not show you those holes in the graph because they do reduce the function before they graph it. So that is something that you will have to be able to find on your own. And that only happens when something cancels out of top and bottom, which is why we take the time to factor them to see if anything will cancel out. All right. So we are just going to start graphing some rational functions today. We'll do some together, and then I will give you some to try on your own. So here is our first part. I want to graph r of x equals -1 over x squared plus 4x plus 4. what did we write down would be our first step?
Factor in both the numerator and
Okay. So the numerator is just -1. That can't factor. On the denominator, what multiplies to 4 and adds to 4?
2.
So you could write that twice. You could also write x plus 2 squared. That would be fine. Then I asked you to find an x-intercept. How do we do that?
Y equals 0.
Y is what this is equal to. So it's just like setting the whole thing equal to 0. But what would you do at this point to solve it? You would multiply the denominator over, right? What's 0 times anything?
0.
So we get 0 equals -1. Does that work? So there is no x-intercept here. How do we find the y-intercept? So if we put in zeros for all of our x's, it doesn't matter if you use the original or your factored one. 0 plus 2 is 2 times 2. So that's -1/4. Then I want my asymptotes. So vertical asymptote, vertical is x equals, what makes the bottom 0? -2. That's what we were doing yesterday. Then we have to decide if it's horizontal or oblique. So what is the degree of the top?
0.
And the bottom?
2.
So if the top is smaller, we said it was going to be a horizontal, y equals what?
-x plus 2.
Look back at your notes from yesterday, your horizontal asymptotes. If the degree on top is smaller, what's your horizontal? Your y equals c. Okay, so now we plot everything. We don't hit the x-axis. We hit the y-axis at -1/4. Vertical asymptote at -2. We draw those asymptotes as dashed lines. And the horizontal asymptote at 0. Then we can use our graphing calculator to fill in the rest. I recommend graphing the original. Just get in the habit of putting parentheses around the top and the bottom. Everybody should graph it. So we have a vertical asymptote. We should have a piece of this graph on either side. To the left of the asymptote is the piece above or below my graph? Below. Now, if you draw something like this, that's wrong. This is a function. It has to pass the vertical line test. Asymptotes are lines that we are getting close to without actually touching. So when you draw this in, it should be curved. I should be able to see that your line is getting closer to your asymptotes. If you're not drawing it getting closer to your asymptotes, you will lose points. Over here, this is also below, but we do know we have to hit this intercept. So it should look something like that. So when I check these, I'm looking for, are your asymptotes and intercepts in the right spot? And is your curve approaching your asymptotes?
Looks different. What'd you think?
You're going to do the very first part. So
There's
-1/.
-1/x plus 2 squared. Okay.
You did put parentheses around the denominator. You did put parentheses around the denominator. You want to divide by that whole thing, so it has to have parentheses around the denominator. Other questions? Or anyone else not good?
Right, thank you. Okay, she said to be pencils on
Did you get that?
no.
This. Okay, let's look at this one. So first step is to factor. Make r of x equals x squared minus 4 over x squared. How does x squared minus 4 factor?
X minus 2x.
And the x squared, you could write it as x times x, but you don't really need to. We can just leave it. B, how do we find an x intercept? So you're just setting this equal to 0. And every time when you set it equal to 0, you're going to multiply the bottom over. And 0 times anything is still 0. So an x-intercept is really what just makes the top of this fraction equal 0. So what's that going to be?
2 and maybe.
How do we find a y-intercept?
X0 would be.
So, yeah, we can do the original or the factored. I'll just go to the original. If I put in zeros, I get 0 minus 4 over 0. Can you divide by 0?
No.
So there is none. Vertical asymptote. X equals what makes the bottom 0? 0. Then we have to decide if it's horizontal or oblique. What is the degree of the top?
2.
And the bottom?
2.
So if it's the same degree, we said horizontal.
It'd be divided.
So 1 over 1 is 1.
Why is it 1?
When it's the same degree, you divide leading coefficients. So 1x squared over 1x squared, 1 over 1.
Where's the negative 4 go?
It's not the leading coefficient, so we
just
don't use it. Okay, so we hit the x-axis at positive 2 and negative 2. We don't hit the y-axis. We have a vertical asymptote at 0. Horizontal asymptote at 1. And then we need to graph. I prefer to plug in the original, but again, you have to put parentheses around the top because it's more than one term. So is the first piece above or below that horizontal asymptote?
Above.
Yeah. We have to go above the x-axis here, but then we're just getting closer to. Our asymptotes. You're not actually hitting those asymptotes, you're just approaching. Yeah, you need the top in parentheses because it has more than one term. Correct.
Hey, that's supposed to be the
Right, it doesn't actually hit it, it's just approaching. It's okay, it's not actually hitting. It's just got close to it. Okay. Let's do some more. So factoring, the top we can't do anything with. What do we do with x squared minus 4?
different two squares.
X intercept. What was the shortcut I told you?
It's
Most likely it's in the
numerator.
Yeah, it's just what makes the top 0. So that would be positive 1. Y-intercept. We plug in 0 for the x's. It doesn't matter if you use the original or the factored. I'll just go with the original. So that would give me -1 over -4. Asymptotes. Vertical asymptote. We want to look at the factored form. Vertical is what makes the bottom 0. So that would be x equals +2 and x equals -2. What's the degree of the top? Bottom? So when the top is smaller, it's a horizontal y equals 0. Okay, so when we plot this, we hit the x-axis at +1, y-axis at +1/4. Vertical asymptotes at +2 and -2. Okay, here's where it's interesting. We said a horizontal asymptote at 0. You notice, don't we also have a point on that line? It's okay, your graph can cross a horizontal asymptote in the middle. It's just the ends that are approaching it, not getting up, or not actually hitting it. So it's okay if that happens. So then do parentheses around the top, parentheses around the bottom, and we'll graph it. So we should have a piece on each side. So we should have 3 separate pieces. What's the first piece, above or below?
Below.
Okay, so you have this curve down here. Make sure it's getting closer to your asymptotes. What's the middle doing?
It's like a chair.
It's like a chair. Starting up, it has to hit the 2 intercepts. Keep going down. And the last piece is up there. I would like to do one last problem and then give you guys time to work individually. Any questions on that one?
When is it in a upgrade? So it's when the tops were higher.
Yes. So x squared minus 1 over x. What do you do with x squared minus 1?
X minus 1 is +1.
Okay. X intercept. Eli, what do we have to do?
Set it equals 0.
Huh? And what part of the fraction am I really looking at there?
The top.
Yeah, so if you just want to jump straight to that, if it's factored, you may just be able to write it down, and that's fine. You multiply over the x and it's gone, so what makes the top 0?
Negative.
How do we find the y-intercept?
Plug in 0.
It'll just be none because
Right, you can't have 0 on the bottom. Right, asymptotes. What's my vertical asymptote?
um 0.
X
X
equals 0. Okay, then we have to decide horizontal or oblique. What's the degree of the top?
Oblique, because it's a 2 and 1, and it's the 1 in
Right. When the top is 1 bigger, that's oblique. How did we find it yesterday? Okay, so we're going to put the x out here. Underneath we have x squared. I'm going to put a 0x minus 1. So what's x squared divided by x?
X.
X times x.
X squared.
Then what do we do with that?
Cancel.
Subtract that off so it cancels. And then we just have a 0x. What's 0x divided by x? 0. So do we even need that?
No.
So our oblique is just y equals x. Alright, so plotting everything. We hit the x-axis at +1 and -1. We don't hit the y. We have a vertical asymptote at 0. Oblique, y equals x. So that's a line. Y-intercept of 0, slope of 1, so up 1 over 1. So your oblique asymptote is just like a dashed line that's slanted. How many sections of this graph should we have? 2. We should have something to the left of the vertical asymptote and to the right. So I always like to do the original to try to catch any mistakes that I might have. Use parentheses around the top because it's more than one term. When you draw this, it's approaching your asymptotes. So it should look something like this. Are there questions here?